so here we go.
Okay. All right. Okay, so you guys can see my screen, right?
Yeah.
Okay, all right, great. So I'm going to try to write and use it to explain certain things to you. So I'm waiting for the software to start. Okay. All right, so mostly you are either hearing AI, and sorry, I've not been writing on this bamboo thing, so my handwriting sucks here. You've been hearing AI, you've been hearing machine learning, you've been hearing deep learning. Usually, when people contact me that they want to get started in AI, the first roadblock is, what should I do? Should I learn AI? Should I learn machine learning? Should I learn deep learning? What's the difference between them? And what is their relationship to data science? Or sometimes when people are hiring, they say we are looking for an AI engineer. Sometimes they are looking for a machine learning engineer. Sometimes they are looking for a data scientist. The question is, which one is which? How are they related? And which one are you supposed to apply for based on your qualifications? So I'm going to try to explain everything. Then before the end of today, I will let us do some hands-on session, not AI yet as of today, but the things we need to be able to do our AI tomorrow. So once we get to the hands-on session, if you have your laptops, of course you can follow through, or you can also wait and get a recorded video so that you pay attention whilst I'm teaching, okay? All right, so somebody said AI is letting computers learn to behave well dynamically in an environment, which is true, but that is a paradigm of AI. So there are multiple paradigms of AI, but the question itself is, what is artificial intelligence? Or what is even intelligence? Intelligence is something that it's even difficult for humans to explain. We have put ourselves on top of the creation tree or above animals and say we are the most intelligent. And yet it is difficult to define what intelligence really is, because history proves that people who were really intelligent were seen to be weird and were seen to be the fools. The Newtons, the Einsteins, they were actually the smart guys, and we were not so smart that when we saw them, we thought they were the fools. And probably they were also seen as the fools to be the fools. It's like the way a madman walks around laughing. Nobody knows why he's laughing. For all you know, all he sees around is a bunch of madmen wearing suit and tie, sitting in a car driving, when in his world of smartness, he can be barefooted and walk around and feel free. Okay, so it's hard to define. But then when we say artificial intelligence, it is about building software that demonstrates intelligence or is able to take smart decisions. And remember, the intelligence here, I'm not talking about the intelligence of a human being. As an AI practitioner, when I see people talking about AI taking over the world and some AI that will end humanity, brother, when you sleep, okay? Once you get practical in AI and you see the limitations over here, we begin to accord less respect to human abilities and accord respect to the man on top who really needs the ultimate respect, okay? So you want to build a system that is able to demonstrate smartness or is able to do things that were otherwise impossible for computers to do. And now you want the computer to be able to do it automatically. In AI, there are several approaches. There are several approaches to artificial intelligence. One of them is machine learning. One of them is deep learning. We also have expert systems, okay? Those ones are very old, like expert systems. They are old approaches where, for example, if they wanted to build AI to be able to detect breast cancer, they will have to take a bunch of breast cancer experts, like human beings who are the domain experts, so they have the knowledge in that domain area. Then they will ask them detailed questions like, what do you do? What do you check for to be able to arrive at the decision that somebody has breast cancer or does not have breast cancer? Then they have to carefully, so it is usually a collaboration between software engineers and the domain experts. So if you are building AI for medicine, then the domain expert is going to be the medical practitioners. If you are building AI to help you do something on construction, then that is going to, the domain expert is going to be the civil engineers that you need to team up with. If you are building AI for football, then it includes every stakeholder in football. So you sit down with all these people, ask them detailed information. And even here, detailed is also relative, because the question is, how do you even ensure that you have asked all the relevant questions that you need to be able to build it? Then at the end of the day, they come up with what is known as fuzzy logic. Why is this not writing now? Okay, please excuse my handwriting. So they come up with what is known as fuzzy logic, okay? The fuzzy logic is going to look something like a decision tree. So let's say if you see a picture, how do you determine whether you see an X-ray of breast or something? How do you determine whether it is cancerous or not cancerous, okay? Then maybe the domain expert will say, we look at the size of, so we look at size and we look at texture, we look at color, and then we assess, let's say, level of pain. Level of pain. This is all fictitious, but you ask questions like this, and then they come up with something like a decision tree, which is actually a bunch of if statements, okay? So it's like, you ask yourself, is the size, so I'm using S for size, is the size greater than, let's say, 27? Let's say they measure in some units. So if it is less than 27, then maybe you don't have cancer or your level is low. But if it is greater than 27, then they go ahead. Okay, sorry, let me clean this. If it is greater than 27, then it is risky. So we need to ask the question, what is the texture? So I'm going to use T for texture. Then I'll say, is the texture, let's say, hard? So I'm using H for hard, okay? If the texture is hard, then you are even now more riskier. If it is no, then we can leave you there. Then it comes, okay, what is the color of that piece of area of your breast, like the skin that they are studying under a microscope or something? Then that is also going to be a yes or no. So let's say if it is red, okay? So you say color is equal to red. Then what is the level of pain? So maybe they can tell you that on a scale of 1 to 10, with 1 being no pain and 10 being the worst pain you can feel, where will you put yourself, okay? Then let's say you say, if the pain is greater than 6, then they can finally arrive at a decision and say that you have cancer. All of these, no, 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 could lead to no cancer. Okay, so this is a rough presentation of what a rule-based system is going to be. But as you can imagine, maintaining such a system is going to be problematic. First of all, it is not going to be accurate enough, because I told you that the AI practitioners in the past who used these expert systems had to make sure that they have asked the correct questions. They have asked the correct question. I have seen somebody I know from physics department, Nana Trimude, how are you? So they have to make sure they have asked the complete set of questions, and they have to make sure they have even taken the answers from the domain experts correctly. And they also have to make sure that they have coded it correctly. So this is going to be a lesson of if. So you can imagine that looking at the code base for such so-called AI is going to be very problematic. And if you are dealing with a situation that is more dynamic, like maybe people feel different levels of pain, even though they have cancer. Maybe somebody is not feeling pain, but they do have cancer. So if your judgment is based on these, then you are not building a very accurate AI. Meanwhile, the focus of AI is for us to be able to get to the point where we can let the computers do the things that human beings are able to do. Now, I'm going to ask you questions. Just answer me, just unmute yourself and answer me. What do you think is the advantage of making computers do the things that human beings do? I want this to be interactive, and there's no wrong answer here. So just unmute yourself and speak. What do you think is the advantage? Yeah, that is number one. So speed, because you see, if you let computers do things, computers have what is known as speed. Like some people will say, oh, my computer is a 2.4 gigahertz computer. That means within a second, the computer can execute 2.4 million instructions. When it comes to human beings, 1 second is not even enough for me to explain the instruction to you. Okay, so speed. What is the next advantage?
Minimum errors, because you can iterate a lot of times.
Thank you. So you see, computers are the most obedient things that human beings have created. They are more obedient than even we human beings. For those of us who believe in God, it is even God doesn't impose his will on us, right? We are free to choose. And so human beings are able to be stubborn. But trust me, we are all programmers. If you write a program, what you put in is what you get. If you are able to write code that the computer should set itself on fire, it will happily do it for you. It will gladly set itself on fire. Human beings will not be able to do that. So it minimizes error and reproducibility. Like you can reproduce something. Let me give you an example. If you see a carpenter or a mason who have built a nice house, and because the house looks nice to you, you go to talk to him that, I want you to make the same thing for me. Chances are that he is not going to make the same thing for you because he's human, okay? So maybe peradventure, when he was building the one you saw, he was in a good mood and he did a great job. But when he came to your place, things got scattered, and you see that instead of building a house that looks rectangular, he'll give you some trapezoid house that when you see, you're not going to be happy. Imagine that if when it comes to things like car manufacturing, if there weren't robots in there, there is no way two Toyotas will behave the same. Even with robots, they don't behave the same. But with human beings, one's Toyota will sound sweet, another one's Toyota will sound like they bought it in Alaba market. It's all because of human errors. Human beings, we get tired. And when we get tired, it shows in our output. Human beings are emotional. When we get emotional, it shows in our output. As you are here, some people are smiling. Some people will not even show their face. Probably they have fought with their wives, their girlfriends, their boyfriends. Somebody is giving them issues. That emotion has gotten into them and has affected the way they will behave. It's the same with computers. Computers do not have emotions. So once you have been able to codify your instructions properly, then these computers are going to follow them to the dot from A to Z without mistakes. So just as an aside, whenever you write a program and the output is not what you're expecting, from my perspective, it doesn't make a whole lot of sense for you to keep running the same program, hoping that the output will change. I know programmers, we do that a lot. Like you run the thing, the output is not what you're expecting. Something in you tells you, let me run it again, maybe it will change. My brother, you run 1,000 times, you will get the same output. So in programming, that statement is true, that foolishness is doing the same thing over and over and over again, yet expecting a different result. Until you change something, nothing is going to change, okay? So these are some of the problems with rule-based AI. Like, the people who are capturing these information can make mistakes. The domain experts themselves can make mistakes. The programmers who are codifying it can make mistakes. So rule-based systems, yeah, they served their purpose. And like everything in life, knowledge is progressive. So now nobody actually talks of rule-based systems. But if you want to get involved, then you can learn about fuzzy logic, okay? You can Google fuzzy logic. I don't see why you would want to do that, but you can just do it for academic reasons, fuzzy logic. So you learn about fuzzy logic, and then you see how these things are done. Okay, so that was just one approach for fuzzy logic, like an approach for AI. Then comes ML. So I'm building up to something. We will get some diagram very soon. Then comes ML, machine learning. Now, machine learning takes a different approach to the rule-based systems. Like I said, in rule-based systems, I have to sit a domain expert down, ask some questions, make sure I'm taking notes correctly, and then I codify the knowledge. So you see, that is what we call knowledge base. You are gleaning the knowledge base from the domain expert. You, the programmer, you are never a medical doctor, but you can sit with a medical doctor and ask them specifically, what do you look out for when you see this, when you see this, when you see this? Then you codify it and you subject it to real life scenarios. So imagine you are building something that determines whether somebody has HIV or not. And you make a mistake, and somebody who doesn't have HIV comes and you tell the person he has HIV. There are some sicknesses, once they tell you, you get it by all means. Even if it's accidental, once they tell you that you have this disease, mentally you will develop it. Or imagine somebody who actually has it, but mistakenly you've told the person that he doesn't have it, and he's going around spreading the gospel according to a virus. Yeah, which is a very dangerous thing. So then came machine learning, which is another approach. The approach in machine learning is that instead of letting human beings pass on the knowledge through code, okay? What I showed here, this is actually code. We have not written it, but every diamond shape you see here is an if statement. I hope you understand. Every diamond is an if statement. And trust me, this is going to be a very ugly program. It's going to be a very ugly program. If, else, if, else, if, else, if, else. And these are nested ifs. You get lost. You get it? So in the machine learning approach, let me show you something that happens in normal day-to-day traditional programming. Then we'll contrast that with what happens in machine learning. So in day-to-day programming, let's think of this as some black box. You put in your data, you feed in your program, which is your program statement in whatever language, and you get an output. For those people who are electronics engineers, this is not a NAND gate, okay? This is a normal block diagram.
This doesn't even qualify to be a gate. It's a door.
So you put in data, you put in your program statement, and the program statement is going to act on the data to determine the output, all right? But so this is traditional programming. I'm going to say TP, traditional programming, okay? Now, when it comes to machine learning, there is a paradigm shift. We twist things around, okay? So in machine learning, we still have the same block diagram. But what do we put in? We put in data, we put in output, and the computer will write the program. Before I take you to the sci-fi world, the program I'm talking about here is not actual source code. So if you're a programmer, don't begin to feel, we are going out of job. No, the program I'm talking about is not the type where some manager can sit behind the browser and say, I want a software that I can use to run payroll. Then you know how they do it in sci-fi movies. Then the screen goes black. Then you see zeros and ones. Then here, program written. Then no, that is false from the pit of hell. The program I'm talking about here is a giant matrix. Okay, we've all learned matrices, like in linear algebra. It's a giant matrix. It could be 1 million by 1 million, 1 billion by 1 billion, 10,000 by 1 million. It's a giant matrix. But the beautiful thing is that the numbers in this matrix codify some patterns and some intelligence that the computer has automatically learned. Do you get it? That is where the fear mongers have a stronghold. Because the question is, if you look at this giant matrix, there is no way you can tell what the computer actually knows. That is true. Do you get what I'm saying? I'd like to hear back from you. Do you get what I'm saying?
Yeah.
Okay.
Yeah.
If you look at this giant matrix, there is no obvious way for you to see what the computer has learned from the data. And yet you will subject it to unseen data and you will trust the output that the computer is going to come out with this. Let me give you a typical example. It was discovered that when a self-driving car is in a situation where it either has to knock a human being or it has to continue its journey. Or it has to continue its journey to avoid an accident. And these human beings, there is a white guy and a black guy. The self-driving car is going to kill the black guy. Now, I'm giving you 10 seconds. Just unmute yourself and tell me, why do you think this is so? Is it because the people who created the AI are racist? Is it because some way, somehow, the car has become racist? Who can give me an answer?
I think I can try.
Yeah, try.
So I think data is going to feed to the learning system. So if you give it data of white people, it only knows white people. So
exactly. Yeah. You see, do you see the difference between the traditional programming and the machine learning approach? In traditional programming, you are in control of the program statement. So then I can look at some features. I'll explain to you what features are. I can look at some features of Black people and codify that in my program statement such that the car would know that Black lives matter. Black people are also human beings, and I don't have to choose to knock them. But you see, go to Google right now and search for business owner and tell me how many pictures you will see that are Black versus white. Just do it. Just Google business owner. It will surprise you. And go to images. Google and then Google for anything and go to images. You can see that for every one Black man you will see hundreds of white people, right? Now, sometimes I don't understand when we Black people cry foul. Yes, I am not looking down on racism. I live in Germany. I have my fair share of racism. But sometimes we cry foul too much. I know some Black AI community who point out these things. Yeah, when you go to Google and you Google for business owner, you see only white people. Who on earth should put the Black business owner pictures there? Who should put those pictures there? So after, it's not enough that the white man has created the internet. It's not enough that the white man has given us access to the internet. Now it should also be their work to go around. Oh, who are business owners here? And then put it there. The internet is there. And you see, as you are getting into AI, very soon you will be making good use of Google Images or open data set, any data set out there. There is voice recognition in my car, and my car struggles to hear my accent. Who is to blame? How many African recordings can we find out there? I'm doing this to throw a challenge to you that for some of you, you are interested in AI. Can you guys still hear me?
Yeah.
Yeah.
Okay.
Yeah.
For some of you, you are interested in a project. I don't have a project to work on, and I don't have something to work on. It can be, your project can be creating data set to balance the imbalance in the data set out there. Okay. So like you Googled and then you didn't see enough of the pictures for people, Black people, you can just take it upon yourself that, Eric, this thing is going to end in 10 minutes. So you don't worry if it ends, let's just rejoin, but maybe tomorrow we need to take care of that. So you take it upon yourself, you're going to create a data set. That's your break into AI task. You're going to just create voice recordings of people and put it out there. You can go to the motorway in your country, and I'm sure most of us here are Ghanaians. You can go set a camera by the motorway and just capture videos of cars driving by, and then crop the number plate and create a Ghana number plate data set, put it out there, so that when other people are creating systems, they can leverage these things to solve some of the imbalance. That was just by the way. So you put in data, you put in output. The question is, what is the output here? You see, there is a reverse. Over here, you put in data here, then you write your program, and you get an output based on your program's logic. But over here, you put in data, you put in output, and it needs to come up with a program. So the question is, what is this data? What is this output? And the answer is, it depends on what you are building. For example, if you are building AI to be able to distinguish between cats and dogs, the data is going to be pictures of cats and dogs. Okay? And the output is going to be annotations or labels. So annotations or labels. What is this jargon I'm throwing in your faces? The data is going to be a picture. The label is going to be, it can be, you can categorize it. So you can say 1 is for cat, 2 is for dog, okay? So you show your AI. Now, when I say it seems some way, but you get it as we progress in the week. You will show the AI model you are building. You show it a picture of a cat, and you tell it that this is a cat. Then you show it a picture of a dog. Then you tell it this is a dog. Then, through the magic of what we know as learning, which is purely mathematical, and is based on calculus, but don't run away yet. You don't need to know calculus to be able to do it, okay? Which is based on calculus. We will mathematically let the model be able to learn from the pixels of the image what it means to be a dog and what it means to be a cat. Now, this also comes with its own problem. Who can think of some of the problems involved in this approach of learning? Like showing data, showing output, and letting the computer sort of come up with a giant matrix, which I say is the program. What do you think are some of the downsides?
Similarities.
Exactly. So you need to show it hundreds of thousands of data points. You see? Otherwise, if you show it your cat and your dog, all your model will be able to know is your cat and your dog. Even if you bring your cat's grandfather, your model will not be able to say that this picture contains a cat. Maybe your cat has pointy ears, or it is a black cat. And so your model will only know that. You see, for those of you who are into electronics, I want you to take this once and for all, that AI models also, like current, takes the path of least resistance. They are lazy just as human beings. It's something that human beings are creating, of course. So models are lazy. They will take the shortcut. And the shortcut here is what? Memorizing. I want you to always remember, memorizing. So for those of you who will follow through and become AI practitioners, the biggest nightmare you will face is you train a model. It is performing 99% accuracy on your training data. You put it in the world, maybe your cat and dog model. You show it donut, your AI says it's a cat. You show it water bottle, it says it's a dog. To make your whole life more messy, you put your own picture there, it says you're a dog. Then you know that life is sweet. So when it comes to AI, you need tens of thousands or hundreds of thousands of data. When it comes to ML, tens of thousands of data points. And what makes it even more difficult is the fact that the data has to be varied. There needs to be variety. So you need to go around taking pictures of, you need to show it a cat on a carpet is different from a cat in the sun. A cat in the dark is different from a cat in daylight. A cat on a green grass is different from a cat that is chasing another woman. You see, when a cat is on heat, they look different from when it is not on heat. All these variations, you need to make sure you capture. Otherwise, you build your model, you see a cat on heat, and imagine you are building a trap to catch cats. And the cats realize that they can bypass your trap when they are on heat. They just have to buy Viagra and bypass your model every time. So you make sure that your data is as varied as possible, which is where the hard work is. So for those of you who become AI practitioners, 80% of your time will be spent doing what is known as pre-processing. As for the training of the model, there are libraries that already exist. Maybe by Thursday, I can show you a few lines of code. We build a model, discover this, distinguish between this and this, do this, this. No, that's the easiest part. It is about getting the data correctly. For those of you who are interested in applying AI in robotics, let's say you are building a robot that should be able to avoid obstacles. There is an easy way of doing it, and there is a better way of using AI. So I have one robot here. Now, on top of this robot, I have this device here. This is a LiDAR, okay? So this guy goes around, he shoots some laser beam, and there's a sensor that records the time it takes for the laser beam to come back. And this thing is 360 degrees, so it's not like your the distance sensor, the ultrasonic ones that is in one direction. This one can tell you the distance around the robot. And this I think is about 10 feet or something, so very long distance, okay? Then you can let this guy scan around, and that becomes your data point. And then you have to determine where you want the robot to move, where you want it to avoid. You can codify all these things, like you can do your data set, and then you build an AI model to be able to learn it. So you can either use one of these, or you can decide to say, okay, I'm going to use a camera. Instead of using a LiDAR, I'm going to use a camera, which means I'm teaching you how to gather your data, okay? And I'm also inspiring some of you to try these things once you've acquired the requisite knowledge. So what you do is you put a camera on your robot. Let's say you want to teach your robot how to avoid falling off the edge of a table. You can easily do this with AI. And I'll be glad to see one of you work on it and share with us on the WhatsApp platform. So you build a toy car with Raspberry Pi, Arduino, whatever. All we need is a camera. Now, you position your car at the edges of your table. So everywhere you think is an edge, you make sure you cover it. Then you take photos. So you can create 2 folders. One folder you call edge. Every folder picture you put in that folder is a picture that shows that the car is at the edge of the table. Then now you can take photos from angles where the car is not at the edge. Then you put it in not edge. So this is the labeling. Do you understand? So your data is actually the pictures and the pixels in them. The label is the categorization. You categorize that this is at the edge, this is not at the edge. Then you can throw this at a model, train it for a couple of times, and now you leave your car, and lo and behold, your car will never fall off the table, except I come to your room and I turn off your light. Then the question is, who